Well, in this short video, we'll just do a couple more examples. And first one says, find the image of triangle ABC and its interior under the transformation given here. Turns out this is a linear transformation. Linear transformation. So what it's going to do to get x prime, I should say, you just double the x value of the ordered pair. To get the new y value, the y prime value, you just double the value of the y prime, of the y value. Okay. Given that these triangle points, the ABC, the vertices of the triangle are here. So let's do this. Let's go like that. Roughly an inch here. We need to go up 2 and to the right 2. 1, 2, 1, 2. Okay, if we plot A, okay, we're just going to put the triangle in this plane. Here's A. And then B is going to be 0, 1, which is here. And then C is going to be 1, 1, which is about here. Okay, so we plotted A, B, and C. Let's go ahead and draw the triangle. Okay, there's the triangle ABC. We'll worry about its interior later. Let's see first, where does A, B, and C, where do those 3 vertex points get mapped? Well, let's say, what is f of A? F of 0, 0. F of 0, 0 is going to be what? Well, the x prime value is going to be 2 times x. The y prime value is going to be 2 times y. So that's our x prime. That's the image of 0, 0. So it gets mapped to itself. Maybe I'll call that A prime. Where does B get mapped? F of B is f of 0, 1. Where does it get mapped? X is 0, y is 1. So what's x prime, y prime going to be? X prime is going to be 2 times x. 2 times 0 is just 0. Y prime is going to be 2 times y, which is 2 times 1, which is 2. That's going to give me 0, 2 is going to be my B prime. B prime is at 0, 2. And then how about f of C? That'd be f of 1, 1. Well, if x and y are both 1, x prime and y prime are going to be 2 and 2. So 2 and 2, about right there. So the 3 vertex points get mapped to these points, A prime, B prime, C prime. And this is a linear transformation, so lines get mapped to lines. So AC, for example, gets mapped to A prime, C prime, that line. And likewise, BC gets mapped to B prime, C prime. And AB gets mapped to A prime, B prime. So the triangle itself looks like it just kind of got stretched, bigger. And hopefully it's easy for you to see that the interior of this triangle will get mapped to the interior of this triangle. One way of picturing it is maybe, if you took that line segment, it's going to get mapped to this line segment. And if you do that with all of the line segments like that, they're going to map to all of these line segments, which basically means the interior of the left smaller triangle gets mapped to the interior of this bigger triangle. So that's graphically what we have here. This triangle and its interior gets mapped to this triangle and its interior under this linear transformation. Okay, one more example. Pretty easy one. We don't have to compute an inverse. We just have to show that the inverse is equal to this. Here's our transformation, or our mapping. F of xy is x prime y prime. And how do you get x prime y prime? X prime is negative x plus y prime is negative 2x plus y. And we just want to show that the inverse of this is this function. It gets us x and y as a function of x prime and y prime, going the other direction. Okay, first solve this system, equations 1 and 2, for x and y. Okay, so it looks like we could just, if we solve these two equations for x and y, we would get, let's see, how do I get rid of the y? I'll just subtract them, right? Let's subtract, yeah, here it is. I just follow these steps. Subtract 2 from 1 and solve for x. Well, if we subtract 2 from 1, I get x prime minus y prime is equal to negative x minus negative 2x is like negative x plus 2x. That's just going to be an x. And then y minus y is 0. Oh, that was nice and easy. We solved for x, and we got x is x prime minus y prime, exactly what we wanted it to be. Okay, substitute this result, the above result, into equation 1 to solve for y. So we're going to replace x with x prime minus y prime in equation 1. And I would get x prime equals negative x is negative x prime minus y prime plus y. Let's see what we get here when we simplify. So x prime is equal to negative x prime plus y prime plus y, just distributing the negative sign through. And then that's going to give us what? I want y by itself. Y equals, okay, add x prime to both sides, 2x prime, subtract y prime from both sides, and we get this. Y equals 2x prime minus y prime, which is exactly what we were trying to show.